Do you want to understand blockchain technology? Well then watch this video and you will soon understand blockchains well enough to explain them to your 80-year-old grandmother. Thanks to this video, you will learn what blockchain technology is, what the different blockchain layers mean, and why major cryptocurrencies like Bitcoin and Ethereum are based on blockchains. A blockchain is a type of distributed ledger technology, and it's the ledger part of distributed ledger technology that is key to understanding blockchains and how they work. So in case you don't know, a ledger is traditionally a book or collection of financial accounts where transactions are recorded. With a blockchain, this ledger is basically like an open database of records spread across a network of computers that anyone with an internet connection can access and not one single person owns. Okay, so what's so special about this open approach? Well, imagine you're in college and your class is voting for who should be the next class president. There are 3 candidates and all your classmates cast their vote. But when your teacher tallies the votes and announces the results, there are some discrepancies with the numbers. With a blockchain approach, it wouldn't just be your teacher counting the vote. Everyone would have access to the numbers and count the votes themselves before sharing their results and coming to a unanimous agreement between the whole class. This approach is known as decentralized. In blockchain technology, this decentralized peer-to-peer approach means the validity of the data and the blockchain itself is not reliant on one single centralized person, organization, or entity. And because a blockchain allows its data to be spread out across a global network of computers, also called nodes, at numerous different locations, it helps keep the data safe because there is no one point of weakness. So if one node fails, there's a whole network of others to help out. But there's another key difference between a blockchain and a normal database, and that's how the data is structured. Databases are usually made up of tables of data, whereas the data in a blockchain takes the form of blocks, and within these blocks is a range of information. Each block is linked to the previous block by cryptography. These links form a chain of blocks in chronological order, and voila, we have a blockchain. Fun fact, the cryptography connecting these blocks of data is exactly where the crypto of cryptocurrency comes from. So that data within each block consists of a variety of information, including a cryptographic hash of the previous block, a timestamp, and transaction data. The fact that each new block contains that cryptographic hash of the previous block is one of the main innovations that guarantees the trustworthiness and security of blockchain. Because each block of data is connected by cryptography, the information within each block cannot be changed once it's been added to the chain. And this is why blockchains are used for cryptocurrency, because they create a transparent, immutable, and distributed ledger that can be shared but not edited. The transaction data within each block can be accessed but not altered or destroyed, and that's exactly what makes blockchains the perfect form of technology for transferring value, aka money, from one place to another. Now, remember those nodes we mentioned earlier? The network of computers spread out across the world? If someone does try to alter the data within a block, the other nodes would not be changed, and so the bad actor is prevented from editing vital information such as the all-important transaction data. This is because in order to validate new entries or records to a block, a majority of the decentralized network needs to agree to it. There are 2 main ways of doing this: proof of work or proof of stake. These are called consensus mechanisms or consensus algorithms, but they're pretty complicated. So let's save that topic for another video. And on that note, don't forget to like, comment, and subscribe to Cryptology for more videos about blockchain technology, cryptocurrency, and decentralized finance. Now that we've covered blockchains in general, let's get into the different types of blockchain layers. There are 3 key blockchain layers: Layer 0, Layer 1, and Layer 2. Layer 0 is the underlying infrastructure on which major blockchains are built, such as Cosmos's Interchain and Polkadot's Parachains. Layer 1 is the major blockchains, such as Bitcoin and Ethereum. Layer 2 are solutions built on top of Layer 1 to scale them and improve their overall performance, like the Lightning Network or Polygon. Imagine blockchains are like an apartment block. Layer 0 is the basement. It contains all the utilities, the car park, everything that helps the other floors operate. Layer 1 is the ground floor with the entrance, the lobby, and the reception area, like the major blockchains people tend to interact primarily with. And Layer 2 houses the apartments themselves, with their own specific gadgets, tools, and household machines. So whereas Layer 1 blockchain projects typically allow for decentralized applications to be built on top of their network, like Ethereum has dApps such as Aave and Uniswap created on top of it, Layer 0 can accommodate entire blockchains built on them. As we mentioned, as well as Cosmos, other Layer 0 blockchains include Polkadot and Avalanche. Now for Layer 1, these are the more common blockchains people tend to be familiar with, such as Bitcoin, Ethereum, and Solana. Layer 1 blockchains are responsible for executing and verifying transactions, maintaining the distributed ledger, and storing the entire transaction history. Layer 2 blockchains most often deal with the issues arising from the blockchain trilemma. The blockchain trilemma describes the three competing goals for cryptocurrency: decentralization, security, and scalability, and the issue that it's impossible for any single cryptocurrency to achieve all three goals simultaneously. It's a really interesting subject that we'll discuss in more detail in another video. So Layer 2 blockchains are developed on top of Layer 1 blockchains to address the scalability, security, and decentralization and the interoperability challenges faced by the majority of Layer 1 blockchains. More specifically, these Layer 2 solutions often aim to increase the transaction throughput and reduce costs while leveraging the security and decentralization of the original Layer 1s they're designed to support. For example, the Lightning Network is a Layer 2 designed for Bitcoin to improve the number of transactions Bitcoin can process per second, which is only about 7 TPS, incredibly slow when you compare it to Visa, the global payment system, which is capable of up to 24,000 transactions per second. Okay, so let's have a quick recap. Blockchains are a form of distributed ledger technology, and they form the backbone of most digital assets, enabling secure and decentralized transactions. As the crypto space evolves, new blockchain layers have emerged to enhance scalability, security, interoperability, and efficiency. The three key blockchain layers are Layer 0, Layer 1, and Layer 2. Layer 0 is the underlying infrastructure, Layer 1 is the major blockchains themselves, and Layer 2 are solutions built on top of Layer 1 to improve their performance. If you've made it this far, thanks for watching, and if you found this video useful, hit that like button and let us know in the comments what crypto topic we should cover next.